Hello friends, in this AV we are going to solve few numericals from exercise 8B of class 10 physics Icse book. Now before we start the exercise, we will have a look at the formulas that we are going to use to solve the numericals of this exercise. If you read the chapter, you will come across these formulas. EMF is equal to work done divided by charge, or work done per unit charge. Then if you have a voltage drop across the cell or in the cell, then that is given as V. That is also calculated as W by Q. Then we have the voltage is equal to current multiplied by internal resistance. Then the third formula that we might need is EMF is equal to current multiplied by R plus R. This is the resistance, and R is the small r is the internal resistance. And if you have more than one resistances which are connected in series, then the sum of the resistance which are connected in series, the sum total is R1 plus R2 up to Rn, or whatever number of resistances we have. Then if we have a few resistances which are connected parallel to each other, then the total resistance of that connection would be Rp, means resistance in parallel, is equal to 1 by R1 plus 1 by R2. If we have more, then it will keep on adding. So this comes as Rp, means the total resistance in parallel, is equal to R1 R2 divided by R1 plus R2. Now let's take a look at the first question of exercise 8B. It says, the diagram in figure 8.42 shows a cell of EMF 2 volt and internal resistance R equal to 1 ohm connected to an external resistance R equal to 4 ohm. The ammeter A measures the current in the circuit, and the voltmeter V measures the terminal voltage across the cell. What will be the readings of the ammeter and voltmeter when the key K is open and number 2, the key is closed? So this is the figure given to us. Now for the first part, when the key is open, we all know that if the key is open, there will be no current passing through the circuit. So here please write the given things. I am directly solving it. So ammeter reading would be 0 as the key is open. Now the voltmeter reading will be, the voltage will be equal to EMF. Why? Because we know that V is equal to EMF minus I and multiplication of I, that is current, multiplied by the internal resistance. Now EMF is 2 volts minus current is 0 and internal resistance is 1 again. So this is equal to 2 volt. This is for the first part. Now for the second part, we have, it says when the key is closed. So when the key is closed, EMF is given as IR plus R. This is the formula that we use. So from here we can find out the current as current is equal to EMF upon sum of the external and internal resistances. So now if we put the value, that is 2 divided by 4 plus 1, that is 2 by 5, 0.4 ampere. This is the value of the current, or the reading that will be shown in ammeter. And for the voltage, we know the formula V equal to IR. We just put the values. We have calculated the value of current, that is 0.4 into the external resistance is R, capital R, that is 4. So if you multiply 4 into 4, 16, and there is a point in between, so 1.6 volts. This is the answer. Now let's take a look at number 3. Question number 3 says, a cell of EMF 1.8 volt and internal resistance 2 ohm is connected in series with an ammeter of resistance 0.7 ohm and a resistor of 4.5 ohm as shown in figure 8.43. We have to find what would be the reading of the ammeter and what is the potential difference across the terminals of the cell. So here, first of all, we'll calculate the total resistance. Before you start solving the question, please write down the given things from the question. Now, total resistance is equal to, if you read the question, that it is 2 ohms, 0.7 ohms and 4.5 ohms. So if we add it up, we will get 7.2 ohm. Now the first part of the question says we have to find the total, what would be the reading of ammeter. So for the reading of ammeter, we will have to find out the voltage. So we know V is equal to IR. Now V is equal to IR. From here we can find out I, that is the current. So I will be equal to V upon R. Let's put the value directly. Now here this V will be the internal EMF, that is internal EMF of 1.8 volt. So here we will write 1.8 divided by 7.2. You can use your calculator if you want. If not, just divide. You'll find that it comes to 0.25 ampere. And the second part of the question says that we have to find out what would be the potential difference across the terminals of the cell. So here again we have the value of current which we have calculated, that is 0.25 ampere, and in this case the total resistance would be these two because they are connected in series. So 4.5 plus 0.7, which will come to 5.2 ohm. Now here the voltage is equal to V is equal to IR. So if we just put the values and multiply, 0.25 multiplied by 5.2, that will be 1.3 volts. That is the answer. Now let's take a look at question number 5. Question number 5 says a cell of EMF E and internal resistance R sends current 1.0 ampere when it is connected to an external resistance 1.9 ohm, but it sends current 0.5 ampere when it is connected to an external resistance 3.9 ohms. Calculate the value of EMF and the internal resistance. So here, to calculate the value of EMF and internal resistance, what we will do is, we have two cases. Let's write them as case 1 and case 2. So number 5, first case 1. Case 1 is current is 1 ampere and when it is connected to an external resistance 1.9. So resistance is 1.9 ohms. We have to calculate the EMF. So EMF here will be equal to E is equal to I R plus R. If we simply put the values, it comes to current is 1.9 plus R. Let's mark it as equation 1. I have a feeling that this sum is going to be lengthy. Now case 2. Now here for case 2, current is 0.5 ampere and resistance is 3.9 ohms. Again, using the formula for EMF, we have E is equal to, or epsilon is equal to I multiplied by R plus R. We simply put the values. Current is 0.5 multiplied by 3.9 plus the internal resistance small r. Now if you multiply, you'll get 1.95 plus 0.5 into r, 0.5 r. Now we have two equations and we have to find out the value of small r. You can use any method. From equation 1 and 2 we have 1.9 plus r is equal to 1.95 plus 0.5 r. Now what you can do is r minus 0.5 r, we are taking this r this side, and this 1.9 going this side becomes 1.95 minus 1.9. So when you calculate it, you will get r is equal to 0.05 divided by 0.5. So if you divide, you will get 0.10. Now this is the answer for the internal resistance. Now if we substitute the value of internal resistance in equation 1, our value of EMF will be 1.9 plus r. So that is equal to 1.9 plus 0.1. When you add it, you find it to be 2 volts. This is the answer. Now let's jump to question number 10. Number 10 says, calculate the equivalent resistance between the points A and B in the given figure if each resistance is 2.0 ohms. So we have named it here R1, R2, R3 and R4. So here it's given that R1, R2, R3 and R4, they are all 2 ohms. Now we see that these two resistances R1 and R2, they are in series. Then R3 and R4, they are in parallel, and the combination of this two will again be in series with R1 and R2. So here we will have to apply series and parallel, some of the series and parallel resistances quite sometimes. So R1 is equal to R2 is equal to R3 is equal to R4, that is equal to 2 ohms, which is given. Now let's say R prime, that is R1 plus R2 here, which are in series connection. So the sum of the resistances of the combination series is R1 plus R2. So here we will get 2 plus 2, that is 4 ohm. Now for R3 and R4, they are in parallel. So let's say that this is R prime. So for parallel combination, we take it as 1 by R. So here 1 by R3 plus 1 by R4. We have 1 by 2 plus 1 by 2. That will be 1 again. So 1 ohm. Now again, to find out the total resistance, even if I take, when I take the reciprocal of 1 by R prime or R double dash, it will be 1 only. So now the combination of total resistance will be the sum of these two. So therefore the total resistance R is nothing but the sum of R dash and R double dash. So that is equal to 4 plus 1, that is 5 ohm. Now remaining, there are more questions of the same type which you can try on your own. If not, then you can ask me in the class. We will now go to, let's try question number 18. It says, in the network shown in the figure, calculate the equivalent resistance between point A and B and A and C. See, for the first part, that is, we have to calculate the equivalent resistance between point A and B. So here, when you go from point A to B, you will come across point D and C. So when you take this path, they are all in series connection. But here, as you can see in the figure, we have marked it like this: R1, R2, R3 and R4. So R2, R3 and R4, they are in series, and the equivalent resistance of the series is in parallel with R1. So keeping this in mind, let's try and solve this. This is number 18. So here R1 is equal to 2 plus 2 plus 2. Let's say that we are taking the combination of this and this as R1. This equivalent we are taking it as R1, and this one we are taking it as R2. So this will be 2 plus 2 plus 2, that is 6 ohm, and then R2, which one is the one which is in parallel, is 2 ohms. So the equivalent resistance will be, as these two they are in parallel, so the equivalent will be 1 by R is equal to 1 by R1 plus 1 by R2. So 1 by R1 is 6 and R2 is 2. So this will come as 12. Yes. So 4 to 6. 4 by 6. But this is 1 by R. We have to find out the value of R. So therefore R is equal to 6 by 4. That is 1.5 ohm. Now for the second part, it says between point A and C. So between point A and C, these two are in series, but their combination is in parallel. So similarly, we will take these two as R1 and these two as R2, and then we will calculate for the parallel resistance. Now for the second part, between point A and C, here R1 is again 2 plus 2, because we are considering R1 for these two. Combination of these two we are considering as R1, and combination of these two we are considering it as R2. So 2 plus 2, 4 ohms. Similarly R2, that is between point AC via B, is again 2 plus 2, that is 4 ohms. Now the equivalent resistance of the circuit, these two and these two, they are in parallel to each other. So 1 by R is equal to 1 by R1 plus 1 by R2. We can simply put 1 by 4 plus 1 by 4, that is equal to 1 by 2. Now this is the value of 1 by R. So we'll take the reciprocal and we will have 2 ohms as the answer. Let's try number 24. It says, in the given figure, calculate the total resistance of the circuit, the value of R, and the current flowing in R. This is what they have given to us, 20 ohms, and this is the unknown resistance, capital R. Ammeter shows 0.4 A or 0.4 ampere, and voltmeter reading shows 4 volt. Now with this we have the information 24. What is given is voltmeter is showing 4 volts, current is 0.4 ampere. Let's say that the total resistance is R prime. Why we are taking it as R prime? Because we have two resistance, so the total will be R prime. Now we know the formula, V is equal to I R, but here we are talking about R prime. So from here we can find out R prime. R prime will be equal to V by I. We have put the values, that is V is 4 divided by 0.4, so that is 10 ohms. This is the answer for the first part. Now for the second part, we have to find out the value of capital R, that means the unknown resistance. So for unknown resistance, R1 is 20 ohms, R2 is, we have to find out, and the total resistance R prime we have found out as 10 ohms here. So we know that the total resistance, these two are in parallel, so the formula for equivalent resistances in parallel, 1 by R prime is equal to 1 by R1 plus 1 by R2, or we can say 1 by R2 is equal to 1 by R prime minus 1 by R1. So 1 by 10 minus 1 by 20. Just calculate. It will be again, it will be 20. So 2 minus 1, it will be 1 by 20. Now this is the reciprocal, so the value of R2 will be just the reciprocal of this, that is 20 ohms. Now for the third part, it says find the current flowing through R. So for this, we have the value of R as 20 ohms that we have just calculated, and the voltage is 4 volt. Using the formula V is equal to IR, we can calculate the value of current. So current will be equal to V by R, that is 4 upon 20, 0.2 ampere. Now after this, number 25 is also important. So number 25 says a particular resistance wire has a resistance of 3 ohm per meter. Find the total resistance of 3 lengths of this wire, each 1.5 meter long, joined in parallel. Next we have to find the potential difference of the battery, which gives the current of 2 ampere in each of the 1.5 meter length when connected in parallel to the battery. Now the third part of the question says the resistance of 5 meter length of the wire of the same material but with twice the area of cross section. Now here what is given is resistance of 1 meter wire is 3 ohms. Now they are saying that there is wire which is 1.5 meter, so the resistance will be 3 into 1.5, that is 4.5 ohm, and we have to calculate the equivalent resistance, that is 1 by R, because it is joined in parallel. So 1 by R1, that is 4.5, 1 by R2, which is also 4.5, and 1 by R3, which is again 1 by 4.5. So please do the calculation and then take, it will be 4.5, 1, 2, 3. So R will be 4.5 divided by 3, that is 1.5 ohm. Now part B of the question says that here the current is 2 ampere. Okay, so let's write current is equal to 2 ampere. We know that V is equal to IR, so I is 2, R we have just calculated 4.5, so that comes to 9 volt. Now the third part of the question, where the resistance of 5 meter length of the wire of the same material but twice the area of cross section. So now for the third part, R is equal to 3 ohms, which is for 1 meter. This is given in the question. Now for 5 meter, R will be 3 into 5, that is 15 ohms. Area is doubled, so area is doubled, so twice the old area, that is twice A. Now we know that resistance is inversely proportional to area, so R will be half. Now this is the answer, or we can simply say 15 by 2. So therefore R is equal to 15 by 2, that is 7.5 ohms. Now let's try number 28. Video is already very long, so I'll just do 28. 30 and 31, please try it yourself. If there's any doubt, we can talk about it in class. So question number 28 says, the circuit diagram in figure shows 3 resistors, 2 ohms, 4 ohms and R ohm connected to a battery of EMF 2 volt and internal resistance 3 ohms. If main current of 0.25 ampere flows through the circuit, find the potential difference across the 4 ohm resistor, potential difference across the internal resistance, potential difference across the R ohms or 2 ohm resistor, and the value of R. So I'm just doing it here. For number 28, first part, R is equal to 4 ohms and current was given as 0.25 ampere. So V is equal to IR. So when you multiply these two, you will get 1 volt, the value of V. This was our first part of the question. Calculate the potential difference, that is V. Now second part of the question is, we have to calculate potential difference across the internal resistance, that is small r. So internal resistance small r is 3 ohms. Again current is the same, that is 0.25 ampere. So V is equal to I. Now small r, okay, this R, which is the internal resistance, so 0.25 into 3, so this comes as 0.75 volt. The third part of the question says we have to calculate the potential difference across R ohm and 2. So I'll just write the formula. So here we have written the given things. I is equal to 0.25 ampere, EMF is 2 volt and internal resistance is 3 ohms. So using this formula for EMF is equal to I R prime plus 3. Now EMF is 2, current is 0.25 R prime plus this is your resistance or internal resistance. So this is equal to 2. We have just substituted the values. When you calculate, you will find R prime to be equal to 5 ohm. Now we can see here that these two are in parallel. So using that formula, R is equal to R1 multiplied by R2 divided by R1 plus R2, that is the equivalent resistance for this. So the total for this series, we will find, we know that this is equal to this. So for the parallel, 2R by 2 plus R plus 4 ohms is equal to 5 ohm. This is from the figure. Now when you solve this, just simplify, you will find that R is equal to 2 ohms. Now this is part D, question number 28, part D. So I'll not be solving this again. And using the parallel combination for part C, that will be equal to 1 ohms. So V is equal to IR. Current is 0.25 and R will be 1, so that comes to 0.25 volts. Here now please do not wonder from where we have got this one. This is simply from here. We have calculated the value of R, which comes as 2 ohms. So 2 ohm and 2 ohm, they are in parallel. So when you find out the equivalent resistance, it will be 1 ohm. That is the one we are using here. So we'll stop here. The video is already long. Please try question number 30 and 31 by yourself. If you have any doubt, you can get back to me. Thank you so much. Happy learning.